That scalding sip isn't a manufacturing defect. It's a behavioral intervention. Your mug is a thermodynamic disaster, and thank God for it. Let's talk convection. Hot liquid meets cool air. Energy jumps ship. Your coffee loses thermal efficiency faster than a startup in a bear market. But the real bottleneck, the handle. Heat conducts straight through that ceramic bridge. Your fingers learn thermodynamics the hard way. Structural stress builds. Your palm sweats. The mug is actively fighting you. People call it a flaw. I call it a pacing mechanism. You want a drink, you wait, you breathe, you respect the brew. The burn forces analog interface design. Back in 1965, engineers didn't care about your palate. They cared about thermal mass. Thick walls meant heat retention, and a handle that could melt your grip. But wait, what about the lid? You think a flat ceramic disc solves the steam problem. Wrong. It traps vapor. Pressure builds. You get a scalding geyser. Classic latency issue. That burn forces mindfulness. You can't scroll while your tongue is filing a worker's comp claim. It's a throttle. It regulates consumption velocity. Drink too fast, you trigger the pain receptors. Oh, you prefer double-walled glass? Cute. That's a weak design choice. Zero thermal bridging means zero feedback. You're just holding a heated laboratory beaker. Skill issue. Ceramic has high specific heat capacity. It drinks the energy, stores it, then politely hands it to your palm. Aluminum would conduct like a lightning rod. Porcelain strikes the balance. Watch the steam. It's not just vapor, it's a convection current. Hot air rises, cool air dives. The mug is a tiny weather system, and you're the hurricane. The burn is a throttle. It regulates consumption velocity. Your brain hits pause. Efficiency achieved. Stop apologizing for the scald. Embrace the thermodynamic chaos. Drop your mug type in the comments. And remember, if it doesn't test your tolerance, it's just a fancy bowl. Subscribe for more brutal engineering truths.